Click the bell icon to get latest videos from Ekeeda.
Hello friends, today we are going to discuss about the recovery and what is the importance of atomicity that we have to maintain within this recovery techniques. We will know that how we can deal with the transaction commit, the log redo and undoing, the concurrent execution within this recovery, and finally we will talk about how a log can be performed to this undo and redo recovery to get the atomic nature of these transactions. Now that we know that a transaction must be atomic in nature, so it is its inherent property based on the acid, that is atomicity, consistency, isolation, and durability. Now, atomicity is a primary requirement of a transaction to make the data inconsistent while they can be performed in isolation so that the database can contain an durable result. Now, what happens? Let us take our example of a banking statement and see that how we can recover from the situation that we will describe below. Now, first we need to take that there are two accounts A and B, from which A $50 will be deducted and B $50 will be added. So now we have A's primary value is 1000 and B's primary value is 2000. Now we need to deduct A from 50 and B with 50. Now what happens, say after that there is a buffer BA which has updated properly to the database, but there is a buffer BB which is not updated till now. Now the result will end transaction in an inconsistent state, and also we can see that the results are not in atomic nature. Because what we can say that a transaction is completed when there will be a 50 deduction from A and 50 addition with account B. Now what we are having that there the buffer, first we need to maintain the log record for all A, and now that we are buffering this value with the 50 and updation of 50 is 950. So now my BA is containing 950 and that it writes to the account A's value to 950. Now my BB has the account which is containing 2050, but what happens that this 2050 is not written till the database. Now my database is containing B equals to 2000, which leads to an inconsistent state, and also the atomic nature is not satisfied. So in that case, what we can do? So there are other states where we can reach in an inconsistent as well as non-atomic nature of a transaction. Now say suppose that there is a problem in transaction TI and it misleads the value of B is deducted with 50 and A with this 1000. That means if there is a deduction from B and A becomes the original one. So now my BB has been written to the documents or the database, but my BA or the buffer has not been written. So now my BA is having $1000 and BB is happening with $1950. So that this 1950 has been written to this B, but not this one is written. So we are having this A as $1000. Not the updation of the value 950 or say 1050 is being performed in this A. Other than that, it can also happen that both of the data are performed in the buffer, but they are not updated to the stable storage. That means the data has been performed by this TI, that is TI is making A minus 50 and also B plus 50, but that has not been written to the buffer till now, so which the transaction becomes inconsistent and atomic or non-atomic. Now all these three cases will lead to the transaction to unfailure, and we need to recover for them transaction inconsistency. We cannot let the transaction commit until and unless all of its operation has been made to the stable storage output. And before making the stable storage output, first the log records we need to make to this output and modification, that this type of modification we are going to have in this database. Now, before going to this log records that we will describe later, we are first going with the database modification. Now, our database will need to be modified as a final result of any transaction. Even if the transaction is fetching some data, then also it is showing a result, that the portion of the data that we can see in this type of databases. Now, what is happening here, that the transaction needs to be performed in 3 stages. Number 1, the transaction is performed in its own private memory area. So say suppose that there is a memory area MI to which TI is belonging. So the transaction is performed on this MI. Now MI being updated on this particular TI. Now what happens, this memory area MI is being written to a disk buffer which is holding for the transaction TI. That means we are needing a buffer space for every transaction which can be freed up after the data has been written to the database. Now the second stage goes with that BI updated with the value of MI. So now we need to update our disk buffer, say BI. Now finally the BI need to be read to these databases. Now BI, or the database portion on modification with this buffer that has been written, the modification with the transaction need to be written this particular buffer. Now eventually in this update we can free up the space of BI. And also we can free up this MI after we have updated that to our disk buffer. So in this way the transaction performed and it makes its updates to the database and finally modify the database with a consistent and atomic transaction result. Now as the transaction modifies the database, it can be done in 2 ways. The first one is in deferred database modification and the second one is an immediate database modification. With the deferred database modification, we consider that this MI and TI and BI being TI has been performed, but this DI to BI has not been performed. That means we have written the transaction to its disk buffer, but the disk buffer is not written to the database till now when we are having an immediate update on this transaction. So now it is being written and all the consequent operation of a particular transaction has been considered to be stored in this BI, and after that we can store this BI to BN, that is I less than N, and store this one to our database D. That means we will perform this one step MI to TI and this 2 BI to MI. Like this we can have BJ MJ till BN to MN, where we are writing MJ based on the transaction TJ and MN based on the transaction TN. So now after having all this BI, BJ and BN, we are what doing, that we are deferring this database modification. We are doing it periodically, say for overnight, or suppose say for 2 transactions, or suppose say for monthly, weekly, in some periodical manner we are doing this modification to the database. So now we can have this number 3 step as a modification D to the set of BI, BJ to BN. So this is what is done within this deferred modification. And until and unless all the buffers that storing at each of the transactions separately cannot hold to these databases until and unless they are modified to the database, and then only they can free up. That means D1 we can have with the update of D, and finally we can have freeing up all the B's, like from BI, BJ to BN. So after that, we are having updating the database modification and freeing up all the disk buffer. Consequently, we can free up all the memory areas. Now we can see that the immediate modification and the deferred modification has only one difference, that in immediate modification, after each of the transaction or the operation even in the transaction, whenever there is an update, we can update the value at that instance to our database. So not only a transaction, even if they're inside the transaction, there are many operations, considering many modification to the database, they will be done at that instant when the operation is being performed. So this immediate and deferred database modifications are both useful in some ways. While we are talking about this immediate modification, because deferred modification, we can just do this immediate one, having all the transactions concurrently or all the transactions periodically modified to the databases. Now today we will talk about the immediate database modification. Now the database can be modified on the transactions in two of the cases. The first one is that the transaction has written to the disk buffers and the disk buffers are already written to the transactional memory area, but the buffers are not written to this database till now. That means the third step is not performed, that we cannot have this DI to BI, but we have performed this MI to TI and BI to MI. So now we can have a problem that lead to an inconsistent state of the transaction, because we do not know the fate of the transaction, but we have partially committed the transaction in any way. And the second problem is that the transaction has modified the database and is in active state, but after that it cannot complete its execution, so that it has to abort. That means, say suppose we are having a transaction TI with operations O1, O2 and O3. Now, as in an immediate database modification, O1 and O2 has been written to the database with this DI1 and DI2 modification. Now what happens that after this O1 and O2 has been modified the database, O3 cannot complete the transaction TI and TI aborts on this O3. But as we have already modified the value of DI1 and DI2 to the database itself, now there will be an inconsistent state that the transaction is occurring, and also as O1 and O2 has performed and O3 cannot be performed anymore because the transaction is aborted, we cannot go further for the transaction's atomicity. So both of these conditions are not been satisfied, so we need to recover from this one, and we need to problem with this immediate database modification with the first one. Now, as because the database modification is the last one or is the final update that we can make, before that we maintain the log records onto which we can have whatever the transaction is performing on the updates. Now, even if with the immediate transactions, not only we can do this log records to maintain our transactional operation, but also that which transaction is committed, which one is aborted, or which one just ended or by killing itself. Now, how to perform and recover from this database modification? We can do two of this performance on the function that we can perform on these databases. The first one is undo, the second one is redo. The undo operation states with that all the old values will be updated with this performance of a transaction. That means the transaction TI will contain all old values. That means the effect of the transaction has been removed from the databases. So O1 and O2 has been lost their database modification if we undo that particular transaction which belong to the differing operations. Now with the redo, we can have all the new values that has been modified to the databases. That means in some cases we must need or we may need that some of the operations that has been partially committed, and we do not need to go to the further transaction rollback till the start, because this one on O1 and O2 will not get any effect on O3. In such cases, we are performing redo operation so that we can have TI with all the new values. Now we can say that we are having in a situation that the transaction has been performed and it has made its way to the database modification. Now what happens when there is a concurrent execution? At the time of concurrent execution, there are higher risk of recovery. That means there are higher risk of failure or their classification that we can make within this concurrent execution. Now, concurrent execution means that two transactions are simultaneously performing, and maybe at some time they are wanting to access a same data item. Now, what happens when the concurrent execution of a transaction wants to update the same data item? It just follows with that whenever there is a data and it needs to get that data immediately under its execution and it is held by another transaction, then there is a problem. Either they lead to an inconsistent state or there is a problem of atomicity requirement, because now all of the operations cannot be performed together because they have to jump to other transaction so that they can fulfill their need. Now, how we can recover from such situations? Say suppose for the concurrent executions, we are having T1 and T2, two transactions that are executing concurrently. Now T1 has modified this data item X. Now that T1 performs write X as its operation. Now what happens that T2 also wants to perform write X as a part of its transaction. Now T2 has not been supported the write X operation immediately after the write operation on T1 until and unless T1 commits or aborts. So it's need to commit or abort by T1, after which we can perform the write X again on any other transaction. So by this way, we can guarantee that there isn't problem with the T1 and T2 concurrent execution and can recover from such situation. Now another situation that can recover on this T1 and T2 transactions is by providing exclusive lock or a shared lock. Now when the T1 is accessing a data item X, if it is a read X operation, that we know we need to get a shared lock on it. Now whenever it is a write X operation, we need to have an exclusive mode lock. Now what is going on that this read X shared mode lock and write X exclusive mode lock will not allow to get another transaction get access to the same data item if they are having an exclusive mode lock. Even if that a transaction is having a shared mode lock on a data item, then another transaction can have another shared mode lock on that data item, because now they can share the data at the same time because they're reading the data. But whenever is a shared mode lock on T1 on data item X, then T2 or any other transaction cannot acquire even an exclusive mode lock on T. Now we can have the exclusive mode lock as the highest privileges that we can give to a transaction, that is the modification to the database. So either by the commit and abort protocol we can have with the transactions, and otherwise we can have this locking mechanism. Now another operation which can also provide this concurrent execution recovery is in snapshot isolation. What do you mean by giving in snapshot isolation? That for each of the database or the transactions, they are having their copy of the databases. They can make their updates so that they can have it at a later time when they are having updating this D1 and D2. But the problem with the snapshot isolation is that they are too much isolated. That means the updation on T1 to D1, it cannot be seen with the updation of T2 to D2. That means T1 cannot see the update on D2 and T2 cannot see the update of D1. So in this way, we need to manage the database transfers of this concurrent execution and recover them using these three techniques. The next one is in transaction commit. Committing a transaction means that the transaction has successfully completed its all of the operations and now it is in an atomic nature and also it is considered to be in a consistent state. Say suppose we have an TI commit in the log record. Now in the log record we are having TI commit means that all the operations inside this TI has started, completed and now or either ended. Now we can commit this transaction TI. So the TI has been committed on the transactional log record. That means it has made to its way to the buffer but not to the main memory where the disk buffer is storing. Now the database cannot be updated with the TI commit until and unless the log record has been modified to the database. So first we need to make the database with the modification of the log record and then only we can make it to the database. Now this TI commit is followed by that the transaction has been logged into it and then the log has been modified to the database so that we can consider that TI commit has been performed. Even if we have this TI commit in the log record, it is considered to be not done or not committed by the transaction until and unless it is written to this log record database modification. Now what happens that if this log L0 lost in some cases, now even if this TI commit the L0 has made, the L0 will not considered to be written to the database modification, so now TI is not committed. Now TI can either be aborted or we can roll back this TI. Now what happens with this abort and rollback? After the log 0 has been lost, this TI commit has lost also. Now the TI can be aborted because we are considering that the read of TI or the transaction has not yet been there. And the last one is TI rollback, that we need to execute the TI from the beginning again. So now by rollbacking the transaction, we having performed the TI start again. Now what happened with this transaction commit and why it is absolutely necessary? Because without this transaction commit, we cannot perform the atomic nature of a database modification transaction happen. That means recovery and atomicity is extremely needed and related with this transactional commit. Now the commit is the most important protocol that we can have in this transaction, and the commit need to be made to the log record as well as to the database modification with the log record. Now let us suppose have this log record that we are having inside a transaction and how we can perform undo and redo to the immediate database modification that we will consider now and be performed so that the database can be modified in a consistent way and also the transaction is completed in an atomic nature. Now let us consider two transactions T0 and T1. The first one will have the $50 that will be updated from A and also that is $50 that is credited to the account B. So now we can have this T0 with the modification that A is deducted with 50 and B with added with 50. Another transaction T2 considers that in account C, someone has withdrawn from 100 rupees to their account. That means the account balance will be whatever and deducted with minus 100. Now let us first define the functions on the transaction. So now we can see that in our transaction T0, we have first read the value of A. Say it is 1000. Now what we are doing, we are performing in the transactional memory area. So if we can recall that we have modified it with MI, that MI is now having the memory area of the transaction which is doing A equals to A minus 50. Now the MI is performing A minus 50. That means A will be updated with a deduction of 50 only in the memory area MI. Now when we are having this write A, that means the value of this A has been written to this buffer BI. Now it is still now not being written to the database, but only it is written to the disk buffer bi. The same way we are reading the initial value of b, say, which is 2000, and now the mi is again performing the b equals to b plus 50, and now my bi is having read with this write b to it. That means now the value of bi is having 950 and 2050 respectively. Now there is another transaction T1. Now what is happening in this transaction? We are again reading the value of this variable C, say suppose, which is 700. Now what we are doing, Ci equals to C minus 100. That means now we are having in this mj, say for the T1 we are considering mj. Now my mj is having the ci equals to c minus 100, which is equals to 600, and writing c means we are having written to another buffer which is considering the value of this t1 as this bj. So now my bj is having value 600. Now how we can write a log performing all these transactions? Let us write the log now. So now my log will have T0 start, that is the starting of a transaction T0. After that it will have update the value of A 2950. Now it will have written this B to 2050. After that the transaction has been committed, that means the BI has been written. Now when the log is having T0 commit, that means it is just having this BI written to its original portion. Now till the database has not been modified. Now we are having T1 starting its execution, then updating the value with T1, that is C equals to 100 minus deducted to it. Finally, we are committing with T1. Again, by committing this T1, we are only having writing this BJ, that is 600 to it. So now we can have this log as our final log that has been not met any type of problem. Now we will see that if the transaction fails in different situation, how the log, and according to that how the disk buffer and the database will be changed. Now let us look that according to the log how the database will be modified. So these are the values that the databases have for A, B and C. Now first my log starts with T0 start. After that we have A modified 1000 to 950 in its memory area of the transaction. After that we have T0, that is B memory area, to be updated with an addition of rupees 50. Now that the database, that if we can see that this 950 and 2050 will be affected in the database. Now with an immediate database modification, the database will be immediately updated. So my A becomes 950 and B becomes 2050. Now what we can see that after this 1950, the A was not been modified in the database. That means it's wait till all the updation on the transaction that we can have, and after that we update the value on the database in immediate update on the database modification. After that T0 is committed. So till the T0 has not been committed, the database has been updated with an immediate database modification. But with the previous one we have seen with the deferred database modification, all the updation are made till the buffer till on the main memory, not the database actually. Now the T1 starts. We have this T1 updating the value of C. then have updated the value in the database, and finally we are performing this commit on T1. So now in any case that the log is having updated, the databases in this way are being performed and there is a failure in any part of this log or any part of the transaction, then we can perform on the database as we have described previously two operations. One is redo, another is undo. First we will talk about redo. Now when we performed redo TI, what do you mean by this TI? The transaction TI that we are having on this log. Now the redo TI means that we need to put in all the old values of this TI that we can have in the database. That means we need to go for the orders of this 1000 and 2000. Now what happens if this redo TI is happening? Now even if the order in which the TI has performed, if we put in the value on the old value as the same order, we will incur or we may incur in a wrong statement or wrong value that will not lead us to this original database values. Now say suppose that we are redoing the transformation on that particular operation on a transaction in such a way that it is being performed onto the database. Now what happens, say for it the first one is having this write A on this A minus 50. So first one will have this 950 which will be not done, that is equals to 1000. Now what will my B will have, that is was plus 50, so it will be deducted with 50, that leads to 2000. Now we can see that we have reached this database original values. But say suppose that the transaction is a slightly different, that we have transferred 10% of the database on this account A to the account B. Now B is related directly with the account A's information update. So that we can have the update as A equals to A minus A into 0.1. Or say suppose that we are having temp equals to A into 0.1 and deducted A with it. And finally we have B with this temp variable associated with it. Now say what happens. Original value is 1000 and 2000. Now my updated value is 1000's 10% is 100. So that will be deducted from this A, and now my new result will be 900. And for B, the 100 will be added to it. So it leaves us with 2100. But what happens when we perform redo in the exact order that the order on the transaction was being performed? Now my A will be calculated and given back this 10, that will be 100 on this 900. That means my 900 now becomes 1000, and in that case we are having this 900 to 1000. So till now we are having the old value of A. But when B is calculating, it will be calculating the temp which is calculated on A 0.1%. That means now it will be 900 0.1%, that is equals to 90. So it will be minus with 90, not 100. So now we have 2010 as our result, but the previous value on B was 2000. So in this way, we cannot have the exact result if we perform this order on the operation the way it was performed in the transaction. So what we can do, we can either reversely perform the order of the operation, but that may also lead us to the problem that we can have in this immediate modification. So we do the redo operation as a scan of the log and the total log will be redone. That means now we are performing the total log and then perform this redo operation on the log, not the transaction. So that is the facility of redo having in the log not the transaction, to have the actual database values that were the old correct values that we can put in by redoing the transaction. Now with the undo of this operation, what we can do, that this redo ti on redo L0 is being performed to get the new values. But till now we have described this undoing of this operation that happens with a special redo only update. That means we can undo an operation if there is an predicate redo only that is associated with each of this log. Other than that, if we redo the performance of the undo, then we will give back this again inconsistent result that we can have from the data modification on the transaction. Now either we can have undoing all the works, and other than that we can just abort the work. Now how to indicate that our undo has been committed or the undo has been completed successfully, that we have get this previous values on the datas that we are having on the transactions pertaining the old correct values. So how we can achieve that? We can achieve by doing all the undo operations on the log or on a particular operation, and then the ti abort command. So by the help on this ti abort command, we can indicate the log that the transaction ti has been undone successfully, that the transaction has been aborted and no effect on a partial transaction of TI has been made to the database. So finally we have to abort this TI as a result of this undoing. So for the undo we have two of these options that we have to check this one. Now the first one is we need to undo a transaction if the log record consists of this TI start, but there is no log record for the TI commit or TI abort. That means the TI commit or TI abort is being not mentioned into the log, and there is another TJ start that is after the TI start. So this is case 1 when we need to perform this undo on TI. See, the undo is an operation that we can perform on the transaction, not the log, because it is not necessary that entire log is having a problem with every transaction associated to it. It can have that only a portion of the transaction has to be undone its effect, or an actual transaction as a whole need to be undone. So other than like this redo where we are performing onto the exact in scan the log, but we can undo the performance by scanning only the transaction. Now we need to redo an transaction TI if there exists the TI start and there exists either TI commit or TI abort. Now it seems strange that after TI abort has been performed, then why we need to perform this redo on TI? Because the transaction has been aborted and we do not need to get the new values get affected in the database modification. But sometimes it is needed. Let us consider the previous example, and in different parts of the log, if the system fails, then we will see that how the transactions recover from it. Now let us consider our transaction that we have T0 and T1. First T0 read the value, update the value, write the value of A, again read the value, update the value and write the value of B. So now if we can adjust this one in this log, then we can have that first the T0 has started. Next it read the value of A, update it and write the value of A. So now we can have this T0 A 1950. Now again it write the value of A. That means the 1000 to 950 has been written to the database, as if we are considering an immediate database modification. Now again it's read the value of B, update the value of B. Till now we are making the log. So here we can see that after this one, without writing this B, the transaction fails. That means the T0 cannot continue further. So what happens and how it can be recovered? We can perform the undo operation because we cannot have the 1000 to 950 updation in the database modification, but the 2000 to 2050 not present there, because it will lead with 950 and 2000 as our database on the result of this one log T0 start A 1950 and B 2050, because we need to know that first we need to write the log record to the modified database and then only we can update the database. But this write B has not been performed, so the 2050 will not be updated. So we need to undo this operation. So we can undo Ti, by which we can achieve the previous values A 1000 and B equals to 2000. Now let us consider another scenario. Now for this one, again consider the situation that we have completed writing B, started this transaction T1 and then updated the transaction T1 on C, that is deducted with 100. So first we start. Next we are having T0, writing the value to the database. Now again writing the value to the database. Finally we are starting this T1. After that we can here commit this T0. And now we can have this T1 with the C. Now before the write C, the transaction fails or the log record fails to modify the data to this database modification. Now what happens? We must perform undo T1, but also we need to perform undo T0 or redo T0. What we will choose? As per the definition that we have given, that if there is an undo, then the Ti start is there, but neither the Ti commit or Ti abort is present. So now we can see that T1 start is there, no T1 or commit abort is present in here. So now we can undo this operation successfully. But what will happen with T0? That we can have T0 start, and if there is T0 commit or T0 abort present there, then we must redo the operation. So the T0 commit is present there. That means the transaction has been committed. Till now we have not done our schedule or the log, but particularly that transaction which has been committed. So now we can perform redo T0. So what will be my updated database modification after doing undo T1 and redo T0? We can have the values as A equals to 950, B equals to 2050, but C equals to 700. See, the value of C is now my old value of C, but the value of A and B are my new value of A and B that we have just written and committed the transaction. Now considering the third case where we can have the T0 has been started, committed its transaction, T1 also started and committed its transaction. So now we can have the whole record or the portion of the record. So now we have seen that we are having T0, T0 commit and T1 also commit. Now after this log fails. That means the log cannot proceed further. Now we can have this for T0, start and commit both. That means we will redo this T0. And also for T1, we are having start and commit both. That means T1 will be also redone. So even if the log cannot proceed further, or there are more transactions inside the log which is failing or say aborting or committing, we can have the updated value in the database modified with the updation that we can perform in these transactions. So now my A has 950, B has 2050 and C has 600. So now all the three values has been modified, and we can assume that these values are containing the log, and even if the log fails, we have recovered from this log, maintaining the atomicity and the recovery till done. Now we will go to the next part of your section, that is on checkpoint. Now, what is a checkpoint? That if a log record contains the concept of checkpoint, that means till now we have been completed our database modification. So there is no need to check or perform redo and undo in our log if it has a checkpoint after some transaction or some portion of the log. Now, checkpoint is the point till which we consider the log to be completed successfully. After the checkpoint that we have made, then we will check the log to this checkpoint only, not to the starting of the log. Say suppose that we are having some problem on this log, and after this T1 we have one checkpoint. Now after the checkpoint is being made here, there will no need that whatever is inside this log after this checkpoint, we cannot have this one as a part of this recovery, because the log has been checkpointed here. That means we have checked till now the log has no problem. Then why do we need this checkpoint scheme? The first one is the search of a particular log which contains the thousands of instruction, that is the transactional instruction, and the searches become extremely tedious and also expensive because it just wastes the CPU cycles. And the second problem is that even with this T start and T commit, T1 start and T commit, we need to redo this operation. Well, this value has been already updated to 950, 2050 and this 600. But we need to perform the redo again on this T0 and T1 because there is a failure in the log, and we need to perform each of the transaction on this redo and undo and check for it. Now it causes no harm to our recovery, only makes the recovery technique go longer, because already the updated value need to be again updated with the redo operation. So redo operation is basically redundant if there is no checkpoint. So by introducing the term checkpoint or giving this login checkpoint, we can take advantage of these two situations. Now our search becomes small because we will search from one checkpoint to another, and if we can know that from which section that the checkpoint belongs, then we can search only for that portion, not the entire log. Now what happens in the second situation, that after that we have made a checkpoint here and there is a failure after this checkpoint. We do not need to perform redo operation on this transaction T0 and T1 as it has been checkpointed on the log and already update the value on the database modification. That means there will be no problem that we are assuming in this log after having this T0 and T1 has completed its values. So now that are the benefits of having the checkpoint, or that are the need to have the checkpoints. Now how the checkpoint works, it just output all the stable storage to the database that we have made till now. That means A, B, C will be stored into the stable storage. That means till now my database is one in min memory, and now we need to convert them into stable storage that we can have for a non-volatile one. All the disk buffers need to be write to this disk. That means first we need to write the disk buffers to the database disk, and then we make to the database to the final stable storage modification. And also the log records till now we are having, we made this modification to our disk buffers. So we are performing these three operations in reverse order. First the log need to be modified to the disk buffer to be written to the disk, and finally the disk to be made to the stable storage output. So in this way checkpoint performs these three operations to keep the log up to date from time to time. Now the checkpoint can be performed periodically, say after 1 hour or a week or overnight or a month, but it is always better to perform a logical checkpoint on some situation. That the situation is having, say after 1 hour the transaction has been not completed and we have made a checkpoint there. So it is not wise to do so. It is to some logical checkpoint, say after one transaction on the complete or 5 transaction complete, we are performing the checkpoints. Now we can have two constraints to these checkpoints. One is that after the checkpoint scheme has been introduced in the log, no buffer can be updated onto this database on the disk of database until and unless we are finding a checkpoint. And after the checkpoint has been found, then we have to make all the buffers to this database. That means we cannot have the value updated of A and B until and unless we are finding a checkpoint on which we can update the value A, B and C both. That means now the updates are being compacted in a batch and they now has been updated to the disk buffers. So this is one advantage and one disadvantage too that leads to the concept of fuzzy checkpointing. Before that, let us consider that there is one transaction T0, T70 till T100. Now we have made this log that after this T70 has been completed, we are finding one checkpoint L here, and that prevising this 68, 69, 1, 2, every transaction need not to be performed this redone or undone. That is, if belonging TK set of transaction, that is T0 to T70, if there is any TK on this set of T where we can have TK start but not TK commit or abort, we need to undo this TK. Otherwise, we need to redo this TK. So if that is found, then we need to perform the checkpoint L, and say suppose T89 has been a problem on this one, then we need to perform all the redo and undo until and unless we are finding this checkpoint L. That means we need to start from that execution on the transaction and go backwards, roll backing each transactions with this undo and redo operation until and unless the start of this checkpoint L we can found. So in this way, checkpoints can be extremely easy and useful for us, other than the disadvantage of having to wait the updation on a disk buffer, which can be a problem for an immediate database modification until and unless we are finding the checkpoint. But we can overweight this one because the usefulness of this checkpointing. Now there is one another concept that goes with an immediate database modification, that is fuzzy checkpointing. Sometimes some checkpoints allow to logically update a value that is no for a logical update, not the physical update for a particular transaction. Say for this transaction, if we have fuzzy checkpoint here, then we can perform this T0 and T1 has been committing their updates 950, 2050 and 600 before the checkpoint has been performed logically. That means if there is any update that required with this T1C which needs another update of A, say suppose that C needs to be added up with the account A, so we can add this 950 to C, not this 1000 which was the previous value. So that is one logical update that needs from one checkpoint to another checkpoint by giving a fuzzy checkpoint here. The term fuzzy means that we are not having an exact result, but we are beginning our execution with an assumption. So this is all for checkpointing inside and recovery, which is absolutely important to undergo an atomicity nature of a transaction. So that is all for the recovery and atomicity using the undo, redo, transaction commit, concurrent execution, and finally this checkpointing. Thank you for watching this video. Stay tuned with Ekeeda and subscribe to Ekeeda.